Hi everyone, video solutions to two questions for the sample paper given by the CBSE Board for Class 10 Math, Term 2, Academic Year 21-22. This is the basic version of the paper. The two questions that we will be discussing in this video are from the chapter Applications of Trigonometry. Both these questions are relatively easy questions. The first question is a section B question, has an internal choice. The next one is a case study based section C question, right. Conceptually, all three questions, the internal choice 8, we call it as 8A, 8B, and the section C question, conceptually are easy, but they take a little while because there are a couple of steps to be done, as in 3-4 steps to get to the answer. So, it's time consuming, not difficult conceptually. What we will be doing is, most of these are like word problems. You read something, you have to grasp the information. As we read each sentence or each piece of information, we will try and plot it and get a right triangle out of it and understand what is said, what is to be found out, and then get around to solving it. Let's do that with the first question. This is the first internal choice of question A, it's a section B question. A tree is broken due to the storm in such a way that the top of the tree touches the ground and makes an angle of 30 degrees. So, quickly let's plot it. We are going to be carrying it over to the next slide too. AB is AC, let's say, is the tree as it stands. The place where it broke, let's call it as B. The top broken part now makes an angle of 30 degrees. The top of the tree rests on the ground and makes an angle of 30 degrees with the ground. BC is when the tree was standing. It's broken and it is touching the ground. So, we will call this point as BC dash. Length of the broken upper part, it's either BC or BC dash, one and the same. That measures 8 meters. So, BC dash is equal to 8 meters. BC is also 8 meters. When it was standing tall, it would have been BC. When it's broken, it's BC dash. So, it's going to measure the same length, which is equal to 8 meters. What we need to find out is the height of the tree before it was broken. So, we need to find out what is AC. Right. Quickly carry it over to the next slide. We'll take this right triangle as it is. Right. So, this is the break point. AC is the tree as it was standing. B is the break point. BC dash is where it actually rests on the ground. Right triangle A, the right angle at A, angle that it's making with the ground is equal to 30 degrees, which is basically the angle that we'll be using. What we need to find out is AC. We know BC is equal to 8 meters and BC dash is also equal to 8 meters. AC for us therefore is equal to AB plus BC. BC is 8 meters. We don't have to worry. So, we compute AB, we have the answer to the question. So, let's look at right triangle ABC dash, this is our right triangle, to angle at C dash, which is 30 degrees. AB that we will have to find out is the opposite side. The information that we have, we don't have information about AC dash, we actually have information about BC dash. That happens to be the hypotenuse of this right triangle ABC dash. So, we know the hypotenuse. What we need to find out is the opposite side hypotenuse. The trigonometric ratio that we will be using is basically sine. So, if we went with sine of angle 30 degrees, that is going to be equal to the opposite side AB divided by the hypotenuse, which is BC dash, right. So, sine 30 degrees is equal to 1 by 2, AB is what we are trying to find out, BC dash is equal to 8. So, AB is equal to 8 divided by 2, which is equal to 4 meters. What we need to find out is AC. AC is equal to AB plus BC, right, AB plus BC. BC we know is equal to 8 meters, AB we found it to be equal to 4 meters. So, 4 plus 8, which is equal to 12 meters. 12 meters is the height of the tree as it was standing tall. Look at the second internal choice. Again, as with the last part, as we read sentences, let's quickly draw the diagrams to make sense out of it. Two poles of equal height, right, we have two poles, A, we'll call it as AB is one pole, PQ is another pole. The heights of both these poles are equal, are standing opposite each other on either side of the road 80 meters wide. So, they are standing on either side of the road, the width of the road is equal to 80 meters. So, the distance between these two poles is equal to 80 meters. From a point between them on the road, let's pick some point, it's not the midpoint, some point between them on the road. The angles of elevation of the top of the two poles are respectively 60 degrees and 30 degrees, right. So, one is 60 degrees, the other is 30 degrees. The steeper one is always 60 degrees. As you right now, it's flat 0 degrees. When it's straight, it's 90 degrees. The closer it is to 90 degrees, the more vertical it is, the angle is going to be larger. So, this is more vertical. So, this is 60 degrees and this one is equal to 30 degrees. what we need to find out is find the distance of the point from the two poles, right. So, let us call this point to be, let us say, a C. So, we need to find out what is AC, what is PC, knowing very well that AC plus PC is equal to 80 meters. So, we need to find out AC and we need to find out PC. These are the two things we need to find out, right. Quickly get started. Let us just take this diagram to the next slide and process it. So, we have two poles AB and PQ. We will draw only relevant information to start with. So, this is point C. This point C, let us say, is x meters from A, which means if the total distance AP is equal to 80 meters, PC is going to be the balance, which is equal to 80 minus x. Both these poles are of equal height. So, let us say AB is h, which means PQ will also be equal to h. I will start with this right triangle to start with. I will start with triangle BAC, right angled at A. We know angle C is equal to 30 degrees. So, we are going to focus on this right now. I will say what we are doing and then we will do it, right. So, in right triangle BAC, I am going to look at angle 30 degrees. We do not have any values per se other than this AP being 80 degrees. But we have some variables. We have h as one variable, x as one variable, and look at it, we have h as one variable and x as one variable. So, in both these right triangles, right triangle BAC and right triangle QPC, we will try and find out h in terms of x given the two angles available to us. So, I am going to start with right triangle BAC. In this right triangle BAC, the variables that we have are for the opposite side of angle 30 degrees and the adjacent side of angle 30 degrees. So, we are going to be using the trigonometric ratio tan. So, in this triangle, tan of angle 30 degrees is equal to the opposite side h, which is AB, divided by the adjacent side AC, which is equal to x. Tan 30 degrees is equal to 1 upon root 3. This is equal to h by x. So, what I am going to do is I am going to write h in terms of x. So, height according to this particular triangle is going to be equal to x divided by root 3, cross multiplying. We will call it as equation 1, one way of expressing height in terms of x. Let us quickly move on to the second right triangle. Again, let us quickly, we need to plot it for each of these, but we will take only relevant data that is required. This is equal to 80, point C, angle is equal to 60 degrees, right angled here. This is 80 minus x, PQ is equal to h. So, I am going to look at right triangle QPC and I am looking at angle 60 degrees. To this angle, QP is equal to the opposite side and PC is equal to the adjacent side. So, we are going to still go with the same tan. Tan of 60 right now is equal to the opposite side PQ divided by the adjacent side PC. Tan 60 degrees is equal to root 3. PQ is the height of the pole, which is h, and PC is equal to 80 minus x. What did we do here? We wrote h in terms of x. Let us do the same thing here. Cross multiplying will get h is equal to root 3 times of 80 minus x. We will call it as equation 2. Height of both the poles are the same. So, whether you measure h as AB or measure it as PQ, it should measure the same for us. So, we got h is equal to x by root 3 in equation 1 and root 3 times 80 minus x in the equation 2. So, let us equate equations 1 and 2. 1 is equal to 2. In 1, your h has been x by root 3. So, let us write that down. So, x by root 3 is equal to, in 2, the value of h is equal to root 3 times of 80 minus x. Cross multiply this root 3. So, x is equal to root 3 times root 3, which is 3 times of 80 minus x. Translates to x is equal to 240 minus 3x. Take the minus 3x to the left hand side. 4x is equal to 240 or x is equal to 60. Now, what did we have to find out? The distance of the point from the two poles. What did we say the distance of the 2 points from the poles are? Of the point from the two poles are? One is x. So, x we have found it to be equal to 60. The other one, AC is equal to x. AC is equal to x, which is equal to 60. PC is equal to 80 minus x, which is 80 minus 60, which is equal to 20 meters. So, the point is 60 meters from one pole and 20 meters from the second pole. So, look a little more, few more steps than the first part. So, if I were to choose between the two, I would go with 8A rather than 8B, but conceptually not a very difficult one. Let's move on to the section C question. Right. There's a lot of background data. Read it for curiosity's sake. You'll know what lighthouses do and everything. Let's come to the question, right? So again, till this, it's general knowledge. This lighthouse we are talking about is 40 meters high, and its beam can be seen at a distance of 30 kilometers. Good. A ship and a boat are coming towards a lighthouse from opposite directions. We'll see it here, right? So it's a lighthouse. There is a boat and a ship. Both are coming towards this lighthouse, and both these are on opposite side of the lighthouse. Go back and read what we have. Angles of depression of the flashlight from the lighthouse to the boat and the ship are 30 and 60. There's a boat. Angle of depression is equal to 30 degrees. Angle of depression to the ship is equal to 60 degrees, and we know the height of this lighthouse is equal to 40 meters. This is given to us, right? This is told us 40 meters, right? So with this background information, we'll have to answer two questions. Look at part 1. Which of the two, boat or ship, is closer to it? Find its distance from the lighthouse, right? Whichever is closer, find out its distance from the lighthouse. Part 2, find the time taken by the boat to reach the lighthouse if it's moving at 20 kilometers per hour. Start with first part. We're going to be using this right triangle to help us solve this, right? So here we have the angle of depression of the boat is 30 degrees and the angle of depression of the ship is 60 degrees. So angle of depression is equal to angle of elevation. So this is what we have. The steeper the line, the closer it is going to be to the perpendicular side. 60 degrees is essentially the steeper angle, which means this line AC is steeper. So this distance is obviously going to be the shorter distance, because angle of depression of ship is greater than angle of depression of boat. Which is closer? The one that's nearer is basically the ship. Ship is nearer to the tower, nearer to the lighthouse. So which is nearer? We have done. The second part to this question itself, we need to find its distance from the lighthouse, right? We know the height of the lighthouse is equal to 40 meters. We know the angle of elevation or angle of depression is equal to 60 degrees. We need to find out BC, which is the adjacent side to the 60 degrees. So this is adjacent side. What data do we have? We have data about the opposite side. So we're going to be using the trigonometric ratio tan. So tan of 60 degrees, right, which is angle C. We're looking at right triangle ABC, right angled at B. So tan of 60 degrees is equal to the opposite side AB divided by the adjacent side BC. Tan 60 degrees is equal to root 3, AB is equal to 40, BC is what we are trying to find out. So cross multiply, we will get the answer. BC is equal to 40 divided by root 3 meters. So how far from the tower is the ship? The ship is 40 by root 3 meters from the tower, right? Part 1 done. Move on to part 2. Find the time taken by the boat to reach the lighthouse if it is moving at the rate of 20 kilometers per hour. We need to find out the time. We know the speed. Time is computed as follows. Time is equal to distance divided by speed. So what is the distance that the boat is traveling? The distance that the boat is traveling is equal to BD. The speed at which it is traveling is 20 kilometers per hour. So if we compute BD, we have the answer to this question. So we're going to be looking at right triangle EBD to help us get there. This is 90 degrees. What do we have? We have this angle of elevation, which is the same as the angle of depression, which is equal to 30 degrees. To this angle, AB is the opposite side, which is the height of the lighthouse, which is equal to 40 meters. The adjacent side is what we need to find out as the distance. So we're going to be using trigonometric ratio that combines opposite side and adjacent side, which is tan. In triangle ABD, tan of angle 30 degrees is equal to the opposite side AB divided by the adjacent side BD. Tan 30 is equal to 1 by root 3, which is equal to 40 meters, which is AB, divided by BD, which is what we are trying to find out. Cross multiply both BD and root 3, will get the value of BD to be equal to 40 root 3 meters. Now we know the distance BD, it's in terms of meters. We know the speed in terms of kilometers per hour. The units do not match. Let's express this kilometers per hour into meters per minute. Speed is 20 kilometers per hour. So 20 kilometers per hour is equal to 20 into 1000 meters. 1 kilometer is equal to 1000 meters divided by 1 hour is equal to 60 minutes. So it becomes so many meters per minute, right? These two get cancelled. So we have 2000, this 2 will get cancelled with the 60 to leave us with the 3. So that's 1000 by 3 meters per minute is the speed in terms of meters per minute. So time taken is equal to the distance, which we computed to be equal to 40 root 3 meters, divided by the speed, which is equal to 1000 divided by 3 meters per minute. The 3 goes to the numerator, will make it as 120 root 3 divided by 1000 minutes is what our answer is. Basically simplify this. This is going to be 6 times 20. This is going to be equal to 50 times 20. So 6 root 3 by 50 or 3 root 3 divided by 25 minutes is the answer. Before you leave, I want you to do 2 things. 1, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.